Look into the night sky. Every star you see is part of a vast cosmic structure. Beyond them are galaxies, hundreds of billions of them, each containing millions or even trillions of stars. For most of human history, we believed the universe was a permanent fixture. Ancient civilizations mapped the stars and predicted eclipses within a model of reality that seemed eternal and unchanging. While astronomers tracked the movement of planets and stars, the universe itself provided a seemingly static stage. It was the enormous, unchanging container in which everything else happened. This assumption of a fixed background was the foundation of all science. To challenge the permanence of the cosmic stage would require a discovery that altered the basic understanding of reality. In 1915, Albert Einstein's theory of general relativity provided a new explanation for the mechanics of gravity. Einstein's math showed that space and time are physical properties. They can curve, stretch, and evolve in response to the matter within them. When he applied these equations to the entire universe, the results suggested a cosmos that was physically changing, either expanding or contracting over time. At the time, the idea of a moving universe seemed absurd. To maintain the appearance of a static cosmos, Einstein forced a cosmological constant into his equations to keep the math from showing any change. Even the era's most advanced mathematical model was suppressed to fit the belief in an eternal, unmoving stage. Einstein required physical evidence before he would accept that the universe was in motion. By the 1920s, that evidence began to arrive at the Mount Wilson Observatory in California. Astronomer Edwin Hubble used one of the world's most powerful telescopes to investigate faint, cloudy objects that many believed were gas clouds within our own Milky Way. Hubble's observations proved these clouds were actually entire galaxies located millions of light years away. He had discovered a universe filled with distant island universes. By proving the existence of these distant structures, Hubble provided the laboratory necessary to observe the large-scale behavior of the cosmos and test Einstein's original dynamic equations. While he was observing these distant galaxies, Hubble noticed that the light they emitted was behaving in a predictable yet strange way. Sound waves behave differently depending on the motion of their source. As a siren moves away from a listener, the sound waves stretch out, lowering the pitch. Light follows a related principle. When a galaxy recedes, its light waves stretch into longer, redder wavelengths, a phenomenon known as redshift. Hubble mapped these redshifts against the galaxy's distances. The farther away a galaxy was, the faster it appeared to be receding. This mathematical relationship, now known as Hubble's law, provided direct evidence that the galaxies were receding from us at speeds proportional to their distance. If every galaxy in every direction is moving away from us, it is natural to assume that Earth sits at the center of a massive outward flight. However, this perspective changes when we look at the structure of space itself. The galaxies are not necessarily racing through a pre-existing room. Imagine dots on the surface of a balloon. As the surface stretches, every dot moves farther away from every other dot. On this stretching surface, no single dot acts as the center. The expansion looks identical from any point on the grid. The cosmic fabric is growing, adding volume to the space between galaxies. On the largest scales, the distance between objects increases because the stage itself is getting larger. As the universe is growing larger today, we can use mathematics to reverse the timeline. Rewinding the expansion brings the galaxies closer together. The immense distances of empty space compress until the entire cosmos becomes dramatically hotter and denser. This logic leads back to a universe that was once infinitely small. This origin point forms the foundation of the Big Bang model. This model describes the birth of the cosmic stage, where space and time emerge alongside the matter and energy they contain. The initial expansion happened throughout the entire universe at once. It established a process of continuous growth that has driven galaxies apart for billions of years. When you look at the stars tonight, you are looking at a universe in motion. The night sky is not a static stage, but a changing process. Because of the time light takes to travel across these distances, looking deeper into the cosmos means looking deeper into the past. The universe is an active, evolving structure. Humanity exists inside an unfolding event that is constantly changing its own scale. And every discovery about this stretching cosmic fabric brings us to the final implication of a growing universe. If the entire universe is expanding, what exactly is it expanding into?